Guys, let's get the old lady out. Okay, my friends, here is the frame as I received it. I just want to show you. It got a slight bend there, I think. And then it got that type of frame. And the only name I can, well, actually not a name, but this is this plate here that looks like a P. So that's the only reference that I have. And this is totally frozen. The handlebar is totally frozen, so I need to get that loose. Okay, the story of this is, a friend of mine and his wife. They are touched to the 70s now, and he said, my friend gave it to me years and years ago. This bicycle was his grandmother's on his wife's side bicycle when she was a girl of about 14 years old. So that's why I guess it must be in the region of 90 years old. So this is a very old bicycle, and that's what I have. And in my stash I've got two wheels which not belongs to that bicycle, because this is 26 inch. It's 26-inch tires, and that frame is 28, if you ask me. But this is definitely not part of the bicycle, but it will work there. And here is all my other stash, which we will pack out now. But if I look, we will need everything there. Bearings and the axle and the pedals and everything there, at least, and a chain to start with, and also a saddle. So let's dig in and see what I've got here, guys. Okay guys, stuff that I think we might use, I'll put on the table. So here is a plastic saddle. We will definitely use that. And then we will use chain. I've got a lot of chain here. So let me put the nice long piece on the table there for us. We can make it shorter. And then we will need at least a pedal. There's one pedal. There's another one. It's not the same, but let's take it out. Here is a hub, but I haven't got spokes, so this will help us nothing. Here we've got, there's a shaft that we can use. So we need bearings. There's one of the bearings, I think, that we're going to use. And let me dig in further. There's the other pedal that is the same. Yeah, we can use rather this one, not this one. Okay, then we need, the important part is where this is on the center shaft. It's something like this, I think. Let's take it out and see. I think there must be another one on the other side. Let me dig a little bit. Okay guys, this project come to a quick halt due to I haven't got the center hubs, in the center of the screen, there's two center hubs that you need where this will ride on with two ball bearings. I've got that. So I've got three shafts to choose from, and there's another one in the box. So, but without that two pieces there, I can do nothing. Further on, I've got everything, guys, to make this project work. I check all the stuff here in my stash, and there's really nothing whatsoever. I'll see if I can sometime find a second-hand bicycle shop, and then we can try again. Okay, so sorry for that. I think we can maybe check if this tires hold air, but I'll have to move on to the next project. Okay, my friends, here is my design for the boat with a fulcrum action. If this is your fulcrum action here, your swivel point, this platform would normally lay flat, like that. So if you have your distance, say 10 centimeter there, or millimeters, doesn't matter, and you have got 40 there, you will have to put a force here, say for instance 1 Newton, to equal the platform out. So there will be a force there. So if this is true, the numbers that I put in here, 40 millimeter, 10 millimeter, if you use the force formula, you will have 10 millimeter side on this side, which move more or less 2.5 to 3 millimeter up and down. This is now attached to the engine. So you will have then, with this ratio, a 10 millimeter up and down, and that is what I want. You remember I need 10 millimeter to make a round there. I had only 5. So if I have 10, when it is in that, from that position to that position, so this is now in the upright, I've got a stroke of 10. So actually my lever is wrong. It would now be on the upright position, and then when it makes it turn down, because that is 5, you remember, so it's 5 up and 5 down gives me 10. So this will enable this to turn with a 10 millimeter stroke that I get from a 40 millimeter bar that swivel on a 10 millimeter on this side, and here is an up and down motion of the smaller motor between 2.5 and 3 millimeter, depending on the clearances on the pivot points and so on. But I will check it out. So I think, Ed, you can say if I'm wrong, but this is what I understand I must do. So it will swivel here, and it will swivel there, and it will make its turn. And I'll show you the picture now, but I get my calculations based on force formula. So here is my design. So this will be the engine, and with a 2 or 3 millimeter up and down there, and then there's the fulcrum with 10 and 20, and that gives me 10 there, and a 5 millimeter there that will ensure that I make a turn there. But what I see, I will have, if this work, I will have to put a heavy flywheel on the shaft. Remember, this is stationary. Here it is. You remember, this is stationary, this part. So I'll need to put the flywheel there. Once it make a turn, the flywheel must just take it over and just take it over so that you don't stop there or tend to come back. So there must be a flywheel. So this is the current position or how it looked basically. And this is what I'm going to build. I think I've already made this part, but I didn't do calculations. So I think this is what I'm going to try, guys. You can tell me if you think I'm totally wrong. You're welcome. But this is what I came up with. So this is, again, another design in my little design book. And we will take it from there. You can see there's from the previous ones and so on. Okay, my friends, I hope you hear anything from you to agree or disagree what I say. And I also, the flywheel action will help the spring going over, although it's not so stiff. But this action works very nice actually. Okay, guys, I'll work on that, unless you say I'm on the wrong road again. See you then on the next one. Bye-bye.